In this video, we'll be reviewing angle pairs that are formed by lines cut by transversals. So we first need to kind of remind ourselves what some of the relationship between lines and planes can be. So parallel lines are lines that are always the same distance apart and they never intersect. Remember, we just studied that their slopes are always equal. Perpendicular lines are lines that intersect at a right angle, 90 degrees. Skew lines are lines that do not intersect and they are not parallel. So that means they must not be coplanar. And a parallel plane is a plane that does not, or planes that do not intersect. So similar to parallel lines, planes that are parallel won't intersect either. So we're going to use these definitions and this diagram to help us kind of visualize what this means. So this diagram is showing us planes that are intersecting to create a rectangular prism. Remember that when planes intersect, planes go on forever. So when they intersect, that line that they create where they are meeting is a line and not just a line segment, because the planes go on forever and the lines that they meet at will also go on forever. So even though it looks like the side EW or EN or NZ look like they're being cut off and they're just segments, we know that they all would really have these red lines on them because planes, when they intersect, create lines that go on forever. So for this diagram, there are a lot of different options for our answers here. We just need to identify two parallel lines. So I'm going to say line SK, and to show that it's parallel, we're going to put this symbol, and we'll say that line SK is parallel to line EW. To show that lines are perpendicular, we use this symbol. So you can kind of see the difference between the parallel symbol and the perpendicular symbol. It almost looks like lines that are parallel and perpendicular. So if I want to start with line SK again and pick one that's perpendicular to it, I could say line SL, line WS, or line EK. Any of those would work for us. And then a skew line, remember, is one that doesn't intersect and it's not parallel. So if I want to use line SK again, the SW and EK we said could be perpendicular. Line EW was parallel to it. So those are the only other lines on the same plane there. On the side plane, we would have line SL, which would end up being perpendicular, line IK that would be perpendicular, and line IL that would be parallel. So we need to go off of the planes that this line SK is on. So it can't be the top plane or the left plane. We actually need to kind of look at either this, if you want to think of it as the front of the cube or the bottom of the cube, this line LZ, this other red line, that's going to be a line that is skew to line SK because it is never going to intersect with it, and it's not parallel to it, and it's not coplanar with the SK. So they're on completely different planes. So another line that might be skew to this could be line IN in the back there. We couldn't say line NZ because that would be parallel to line SK. And then a parallel plane, we can kind of just think of this as the opposite sides of this prism that were created. So you could say the plane SKW, and that would be like the top of our figure. That would be parallel to the bottom of the figure, and that would be the plane ILZ. So remember, when we name planes, we just need three non-collinear points. So I also could have named it INZ or plane EWK. There are lots of ways to name them. You also could have said that the sides on the left and right were parallel planes, or the front and back were parallel planes. Now that we've kind of reminded ourselves what those relationships of lines can be, we're going to start looking at what a transversal is. So a transversal is just going to be a line that will intersect two or more other lines. So on the diagrams here, you can see that we have two lines that look like they're parallel. They're not marked, so we're not going to assume, but there's two lines, and they're both being intersected by this line P. And you can see that that happens in each of these diagrams. When we do this here and we have two lines that are intersected by another line, that line P that I've just highlighted is going to be the transversal that cuts through line M and line N. When this happens, it creates angles, and because those angles are created through these transversals, we can identify them as special angle pairs. So the first one we're studying is the alternate exterior angles. So that means that we are going to be outside of the lines because it says exterior, and they are alternating. So they're on either side of the transversal. So I'm going to highlight the two pairs that we have here. We can say that angle 1 and angle 7 are alternate exterior angles because they are on the outside of the two lines. So this would be the inside. Right here is outside. And then for alternate, that means that they're on opposite sides of the transversal. So you can see that 8 is on the left side of the transversal P, and 2 is on the right side of the transversal P. Whereas 1 and 7, 1 was on the left and 7 was on the right. They're both outside of those lines though, so that means they're exterior. So similarly, we have alternate interior angles, and I could see those as angle 4 and angle 6. Or we could have angle 3 and angle 5. So this time it's saying interior. Well, interior would mean inside the line, so we're focused on the inside. We don't care about the outside angles now, we are just focused on the inside. And again, because it says alternate, we are just on opposite sides of the transversal. So 4 is on the opposite side of 6, and 3 is on the opposite side of 5. So these would be alternate interior angles. The next type of angle pair that we have are corresponding angles. So corresponding angles are just angles that are in the same position. So because 1 is on the top left side of the 4 angles created when P intersects with M, then it will be corresponding to angle 5 that is on the left top side of the angles that are created when you intersect P with N. So another set of corresponding angles would be angle 2 and angle 6. They're on the top right side of the angles that were created. The other corresponding angles that we would have in our image would be angle 3 and angle 7. They're on the bottom right side. And then the bottom left would be 4 and 8. So they're just in the same position. So corresponding means same position, same place. So because they're in that same location between their two sets of little angles that they've made there, that means that they will be corresponding. And then the last relationship we're looking at are the consecutive interior angles. So again, we're focused on interior. That means inside. And when we want to look at the angles that are inside, this time they say consecutive. So consecutive means one after another. So 4 and 5 are one after another there because they are right next to each other. They're not jumping the line. They're not alternate interior angles. They are consecutive because they are next to each other. So 3 and 6 would be our other pair of consecutive interior angles because they are inside and they are right next to each other, one after the other. So now that we've looked at these, we're going to try to fill in some of these diagrams here. So we are given two diagrams, and we are looking for what pairs we can find. So on my first diagram, diagram A, I'm looking for corresponding angles. So this first box, corresponding angles in diagram A. I could say angle 1 corresponds with angle 5. I could say angle 1 or 2 corresponds with angle 6. 3 corresponds with 7. And 4 corresponds with 8. So we could just write that as angle 1 and angle 5, angle 2 and angle 6, and so on until we've listed all of the ones that are corresponding in this diagram. Now in the second one, it says look at diagram B for the transversal C. So we're saying that this time our transversal is this line C, and we're looking for corresponding angles. So corresponding angles here would be angle 1 and angle 13, 2 and 14, 3 and 15, 4 and 16. So you can see that the corresponding angles are in the same place, and I was focused on this set of relationships because it said my transversal was C. So I could list them as angle 1 and angle 13, angle 2 and angle 14, angle 3 and angle 15, and then angle 4 and angle 16. And we just write them using that angle notation and saying that those are going to be corresponding angles to one another. I'm going to go ahead and erase these so that we can look at our next example. And in the next question, it says we're looking for consecutive interior angles. So in diagram A, they are looking for those consecutive interior. We look inside next to each other. So 4 and 5 or 3 and 6. And then in our second diagram, it says we are now focused on the transversal line B. So line B was this line. That is now our transversal. We're looking for consecutive interior angles. So because B is the transversal now, the two lines that we cut through are C and D. So we need to look inside of those for angles that are next to each other, next on that transversal. So 14 and 9, and then 15 and 12 are going to be inside of C and D. Cut by transversal B, they're next to each other on that. So we would say angle 14 and angle 9, and angle 15 and angle 12. In the next example, we are looking at the diagrams for alternate interior angles. So remember, when it says interior, we look inside of the two lines that were cut by the transversal, and we are looking for alternate, which means we go on either side of the transversal. So diagram A, the alternate interior would be 5, and then on the other side of the transversal, inside the lines would be 3. 4 is inside of it, and on the opposite side of the transversal would be angle 6. So we could say angle 3 and angle 5, angle 4 and angle 6. In our other diagram, we are now focused on the transversal line D. So if this is the transversal, we are looking at A and B being the two lines that were cut by it. So we're going to look inside between A and B, and we're focused on the angles that are on opposite sides of the transversal inside. So 8 is inside, and on the other side of the transversal would be 10. 7 is inside, and on the other side of the transversal would be 9. So we can label those as angle 7 and angle 9, angle 8 and angle 10. And finally, we have the alternate exterior angles. So again, we're going to be on either side of our transversal, but this time instead of being inside the lines, we need to be outside because they are exterior. So we'll look on the outside of the two lines that were being intersected. So alternate exterior for diagram A, we're looking outside of line M and line N, and we're on the opposite side of the transversal. So I was on the outside top left of my transversal. I'm going to be on the outside bottom right of my transversal to find the alternate exterior. So 1 and 7. That would mean my other alternate exterior angle pair would be angle 2 and angle 8. And then in my second diagram, it says this time our transversal will be line B. So this was the line that cut through line C and line D. So we're looking on the outside of these two lines for the opposite sides of the transversal. So I have angle 13 on the outside of line C, and the other side of the transversal on the outside of line D would be angle 11. My other pair of alternate exterior angles will be angle 16 and angle 10.